Okay, now it's time to go ahead and work on part 2 of the Sedimentary Rock Lab. All right, so in part 1, we examined clastic sedimentary rocks. So now we're going to look at chemical and biochemical sedimentary rocks. Chemical sedimentary rocks are sedimentary rocks that form where the sediment comes out of solution. So it comes out of solution as a precipitate or as an evaporite. And then there are biochemical rocks, which are rocks that form from or by living organisms or their remains. And most of these rocks are formed in an ocean environment. All right, so let's take a look at the processes very briefly. Some chemical sedimentary rocks form as a precipitate. So a precipitate is when a solid comes out of solution, and it comes out of solution when there is some type of catalyst to cause that to happen. So the catalyst can be something like a change in temperature or the introduction of another substance. So those of you going on to chemistry in 2 years will be doing some experiments where you are causing a precipitate to come out of solution. And you'll do that in those two ways, by changing the temperature of the solution or by adding another substance to it. So in the image that's shown there, we have a clear solution of potassium iodide, and it's poured into a clear solution of a solution containing lead, nitrogen, and oxygen. And in a chemical reaction takes place to form the yellow precipitate that you see forming in the beaker. Evaporites are a type of sedimentary rock where evaporation causes the water to be converted into a gas, and that leaves behind a chemical, a mineral material. An example of this is the formation of rock salt and rock gypsum. And then we move on to our biochemical rocks. The most common one is limestone, and there are many different types of limestone. You'll be looking at several types in this lab. Some of them form in marine environments, in oceans, like coral reefs, coquina, chalk, for instance. And others form as precipitates or evaporites. Travertine limestone, which is found in caves, and oolitic limestone are examples. All right, so these are the rocks that we're going to identify. And the first thing we're going to do is, I normally start with seeing if it's limestone or not, but that we're going to have to put hydrochloric acid on the rocks for that, and it makes them wet. So I think we're going to describe them first. So you're going to need your lab paper or Google Doc. So I'm just going to use the paper just out of convenience while I'm filming this. And we're going to describe the rocks. Okay, so we'll start with rock number 8, and I'm going to move this away, the paper, because it changes the lighting. It's black. It appears there are layers in it. It's kind of shiny. It feels kind of lightweight for its size. And there's some cracks in it too. All right, so black, shiny, lightweight, layers, and cracks. Right. Rock number 9. Rock number 9 is gray and tan, and there are obvious fossils in it. This is a fossil right here. It looks like a shell. So it's gray, and there's some, that looks like a broken shell there. So we've got gray, tan, and shells. So ocean organisms. So marine organisms. All right. The next one is tan with some darker colors, some dark gray, some light tan, dark tan, so various colors, but there's obvious layering. There's obvious layering. So it's kind of crystalline too. It looks crystalline. So crystalline, I probably spelled that wrong. I think there's two L's. Now I'm maybe there's one. I don't know. So layering or banding. You could also call that banding. Tan, white, gray. Okay. All right. Number 11 looks like, it almost looks like sand. It's light gray, and it almost looks like pieces of sand cemented together. Kind of powdery too. So light gray. It feels powdery. Looks like sand. Now I wrote looks like because I know this is a chemical rock, so it's not sand. All right, number 12. Number 12 is a light gray rock. It looks pretty dense, and I can't see the individual particles, so those particles are small. This is the only one that I collected here in the Shippensburg area, so it's local. Nothing else is local that I collected. All right, so gray, microscopic particles, dense, and local. That's right, collected in Shippensburg. Okay. This one almost looks like oatmeal that's been cemented together. But it's not oatmeal. Those are seashells. So crushed up seashells that have been cemented together. Okay. All right, last one. Gray has some conchoidal fracture to it. Remember that for mineral identification? Particles are too small, microscopic. And it looks like there's some variation in color, but light gray with darker spots. Start with darker spots. Conchoidal. See? I didn't spell that right. And microscopic particles. Okay, there's all of the descriptions. All right, Now let's go ahead and see if they're limestone or not. So limestone is made of the mineral calcite. And when we did mineral identification, there was one test that you could do on a mineral if you thought it was calcite. So here is a piece of calcite. And in case you missed that during the lesson, I'm going to drop some hydrochloric acid on some calcite. And you know what? I'm going to get rid of that and see if our lighting is better. Try that again. You still can't really see it. It's just this camera and the lighting, but it bubbles and fizzes. Let's try that again. Maybe it's some more. There. You ought to be able to see that. There we can see it because it's bubbling. It's still bubbling on the table. All right, so that's what we're looking for, a reaction. So let's go ahead and test that for every mineral, or rock, excuse me. We're testing every rock for the mineral calcite. So we'll start with mineral 8. So we're looking for some bubbling and fizzing. It's running down the rock. And again, there, that's better. Yeah, I think we got to get rid of the paper towel. There. I do not see, it's a wet rock now. It's not bubbling. All right, let's try number 9. And I'm just going to hold it up a little bit here. That's obvious. That is bubbling. So number 9 is limestone. So for number 8, you're going to write no. Look at that big bubble form. For number 8, you're going to write no. It is not limestone. For number 9, you're going to write yes. Number 10. All right, here's number 10. That is definitely bubbling. So number 10 is yes, that is limestone. All right, number 11. Yes, that is limestone. Number 12. Number 12 is bubbling. It's not giving us the exciting reaction that the others did, but it is bubbling. So number 12 is limestone. Number 13. Is definitely limestone. And finally, number 14. is just wet. It is not limestone. All right. So 8 is not limestone. 14 is not limestone, but all of the others are limestone. So 8 is not, and 14 is not. All right. So back to your other document, the identification document. Number 8 and number 14 are not limestone. They are either chert or bituminous coal. All of the others, 9, 10, 11, 12, and 13 are limestones. Okay, so you've got their descriptions and you know they're limestone. So they are named from those 5. So at this point, you are to identify the remaining sedimentary rocks. I will put them here in order. All right, 9, 8, 8, 9, 10, 11, 12, 13, and 14, if you need to see them again.